Hello, friends. Welcome to this live stream. And today we have a very important question to discuss, and this is about the ultra massive black holes. We know that the ultra massive black hole exist, although they are not too many numbers, but how they are formed, it's a big mystery. And that is what we are trying to solve in our show today. So let's move forward. And we know that there is a supermassive black hole which is in the range of millions of times the mass of the sun, and there is one that exists in the heart of every galaxy. And we believe that these supermassive black holes are basically driving the entire universe. However, these supermassive black holes are not alone, and there is a bigger cousin called ultra-massive black hole, and they are so massive. The starting weight of these giants are almost like 5 billion solar masses. That is really the starting point. And we have seen quite a few of them, but they are not in abundance as compared to the supermassive black hole, because supermassive black holes is found in most of the galaxy in the middle. But there are certain galaxies which actually host an ultra massive black hole. The size of these ultra massive black holes can start from 5 billion solar masses, and so far we have actually seen ultra massive black hole the size of 100 billion solar masses. They are really, really huge. The galaxy that they are hosted in is also huge. Scientists do not know what may be causing these ultra massive black holes to grow so large, many times larger than even the supermassive black hole. So that is the big mystery. But I think to answer such mystery, we need to basically rely on scientific methods, and one of the scientific method is to basically use the simulation. So the simulation that the astrophysicists have been trying to use to answer this question, that how the ultra massive black hole can become so large, is basically feeding in all kinds of information in this simulator, starting from gravity, even dark matter, and also dark energy as one of the parameters, the rate of expansion, and whole lot of other parameters which are required to simulate the universe. So the simulator has been basically at work, and these are using multiple supercomputers, because these simulations can be very, very tricky, very complex. So the simulator is now given us a model which explains how the ultra massive black hole would have formed in the first place. And people generally believe that now, as per the simulator, is that these probably were created about 10 to 11 billion years ago, during the era of cosmic noon. Now let's understand what is this cosmic noon. Probably you have not heard about this before. Cosmic noon is the era when the universe was expanding gradually about 10 billion years ago, and things were not so far off as they are as of now. And since things were very close by, and there was more opportunity for things to collide with each other, and there were a lot of gas available in a smaller area as compared to universe of today. And therefore almost 50% of the star which you see in the night sky today were formed during the cosmic noon. So about 10 billion years ago, the era is called cosmic noon, because almost 50% of the matter that we see, visible matter, was created about 10 billion years ago. So probably now the simulator tells us that the birth of this ultra massive black hole would have taken place at that era, during the era of cosmic noon, because the galaxies were closer at that point in time, and there were a lot of collision, galactical collision, that might have happened during that period. And so basically, to form an ultra massive black hole, you would need at least three supermassive black holes to merge. And the only way these supermassive black holes will be able to merge when there are at least three galaxies colliding with each other at the same time. So when the galaxy collide, it's not only the matter which combines, it's also their supermassive black holes in the middle of these galaxies will also merge into one large, giant, very heavy black hole, which is now known as ultramassive black hole. So that is the answer given by this simulator, which try to solve this issue that how these ultramassive black hole would have formed. So the answer is that during the cosmic noon, multiple galaxies would have merged together, may have collided, and that is the reason for creating ultramassive black hole. So in numbers, as compared to supermassive black hole, ultramassive black holes are not too many. We don't see too many examples, but they are there and they are huge. Once in a while we come across these ultra massive black holes, 50 billion times the mass of sun, etc. They are really huge. The galaxies in which they exist are also very big. So it shows that these elliptical galaxies would have taken birth along with their ultramassive black hole because of the huge galactical collisions that would have taken place during the cosmic noon. Now, the simulator also tells us that these galaxies were so huge about 10 billion years ago, and they must have been very active also. So when we have the active galactic nuclei, these bodies are called quasars. So the chances are that when these galaxies were merging, 2 or 4 galaxies or 3 or 4 galaxies were merging, they must have been active at that point in time. And when we say active, that means they were all quasars. And normally if you look around in our space, quasars are basically huge galaxies. They are bigger galaxies than that we see around. Really, the large galaxies actually have the potential to become quasars. So the chances are that these galaxies, when they merge, 3 galaxies or 4, when they merge, they would have been in their active galactic nuclei stage. That means they must be behaving like quasars at the time when they merged, and because of that their core supermassive black holes would have been eating a lot of material. They were growing naturally even without merging, and when they merged they became ultramassive black holes. So I think the simulator has given us the answer, but where is the proof? So now we are looking at back in time using the James Webb Space Telescope, which is going to look at these big mergers, and probably JWST will help us prove the finding of the simulator. So although this theory is not proven yet, but this is a simulated one, but it gives the best probable answer around the birth of ultra massive black hole. So friends, thanks for watching. If you have any suggestions, any comments, please feel free to write in, and I will catch you again in the next edition of Science Show. Until then, goodbye for now.